You can deploy the most sophisticated machine learning algorithm on the market, but if you feed it the wrong data, it won't generate insights. It will simply make expensive guesses. This chart shows the projected abandonment rates of AI initiatives against successful implementations. By 2026, Gartner estimates that 60% of AI projects will be abandoned entirely because their data is not AI-ready. The Rand Corporation echoes this, finding that missing or inadequate data is the second most common root cause for AI project failure. Up until now, gathering your project requirements has focused on what your organization wants to happen, but somewhere behind every requirement sits the messy reality of what data the organization actually has. We are talking about fragmented customer records in a CRM, transaction logs in an ERP, or physical inventory counts taped to a warehouse wall. For an AI system, data is its only context. Mapping your actual data landscape, finding out what exists, how it connects, and where the gaps are, is the only way to prove whether a project is feasible. To figure out what data you have, you rely on data modeling. Your primary tool here is the Logical Entity Relationship Diagram, or ERD. This platform-agnostic blueprint maps out your business's information structure. You built this blueprint by reading through your business requirements and conducting a noun analysis. The core nouns that recur frequently become your entities. These are the things the business needs to track independently, like customers, orders, or products. The descriptive nouns that modify those core concepts are your attributes. If customer is the entity, their first name, email address, and phone number are the specific attributes that describe them. Next, look at the verbs connecting those nouns together. A customer places an order. An order contains a product. Those action words define the exact relationships between your entities. By parsing the everyday language of your business requirements, you extract the raw materials. You translate conversational statements into a strict, organized architecture. To map out this architecture visually, analysts use crow's foot notation. It is an industry-standard system of lines and symbols that translates business rules into precise relationship maps. Look at this diagram. The branching marker represents a one-to-many relationship. One customer places multiple orders. But students and courses create a many-to-many relationship. Databases can't implement this. To solve it, we insert a junction entity, splitting the connection into two one-to-many relationships. Generative AI tools can instantly translate your written requirements into code and generate a first draft ERD in seconds, but the AI has no access to your company's actual servers. It generates schemas based on industry averages. A retail AI model might suggest you track an inventory entity, even if your specific company dropships and holds no physical inventory at all. AI also heavily favors one-to-many relationships because they are the most common structure in its training data. It will routinely miss complex many-to-many connections and completely skip building those critical junction entities. Finally, AI tends to over-engineer. Instead of keeping the model at the platform-agnostic logical level, it will often output a physical ERD filled with database-specific data types and storage settings that it just invented. AI is a powerful accelerator for drafting, but accepting its output as truth without human validation means building your blueprint on structural lies. Your logical ERD dictates what data should exist. To find out what you really have, you perform a data landscape assessment. This requires hunting down where the data physically lives. You have to figure out if it is neatly structured in a modern database, trapped in unstructured PDF documents, or locked inside a legacy system under strict access controls. AI cannot do this step. It cannot interrogate a stubborn legacy server, unearth a handwritten logbook from a filing cabinet, or interview data owners about missing records. This chart shows the impact of human assessment. According to Tiger Data, when AI queries a database without semantic context, its accuracy hovers around 58%. By providing accurate data context, that accuracy jumps to 86%. Your data models and landscape assessments specify exactly what information your system needs, and they prove whether that data actually exists in a usable form. They answer the only question that matters right now. Is the data context real, or is it aspirational?